Hi everyone, here's another video for Math OED2. This is section 2.3 in our current textbook, which is solving using elimination, and I think the textbook actually refers to it as addition, but it's the same thing, elimination or addition. So if we look over here, remember our end goal is that if we were to add these two equations together, we want either our x's or our y's to cancel out. Now, if I were to go ahead and eliminate this, or add this right now, you can see that I would get a positive 2x and a negative 2y. So neither of these variables right now are going to cancel out. So what that means is that I have to do something first to one or both equations before I can add them together. Okay, and over here on our steps, you can see that I have to choose a variable to be eliminated, right? Which means that they have to have the same value coefficients and opposite signs. Okay, so we could pick either the 3x and the 5x, because again, the 3x is negative, the 5x is positive, those have opposite signs, or we could pick the 2y and negative 4y. This time I'm going to choose to try to eliminate the y variable, and the reason is quite simple. The reason I'm going to choose the y variable is because if I simply multiply the first equation by 2, then that will give me a positive 4y, which will then cancel out with the negative 4y in the second equation. Okay, so let's go through and do this math. 2 times negative 3x is negative 6x. 2 times 2y is 4y. 2 times negative 10 is negative 20. I'm using a different color just to keep track of the original equations versus the modified equations. Okay, the second equation didn't do anything to it, so I'm writing it in black ink to indicate that it has not changed at all. Okay, so now that I've made that modification, let's see what happens when we add these two equations together. So we get negative 1x or negative x, however you want to say that, 0y equals negative 20. Oops, I'm sorry, not negative 20, negative 2. There we go, negative 2. So we can come down one more step, so I have a negative x equals negative 2. You can either divide or multiply by negative 1, and you find out that x is equal to 2. Okay, so let's go back to our steps. So we chose the variable, we chose to eliminate y, and we successfully eliminated y, and we solved for the other variable, which was x, right? And we found that x is equal to 2. So we still have this last step, right, which is to use the fact that x equals 2 to find out what y equals. Okay, and remember, we can use either equation. The important thing is that you go back to the very original equations that were given to you by the problem, not the ones that you modified. So either this first one here that I highlighted in yellow or the second one, does not matter. So let's use the first equation, negative 3x plus 2y equals negative 10. Okay, so wherever I see the x, instead of x, I am going to write 2. Okay, so we get negative 6 plus 2y equals negative 10. Then we add 6 to both sides. I'm kind of out of room here. Okay. So we have 2y equals negative 4. We divide both sides by 2. And we find out that y equals negative 2. So that is our answer. Okay, so we are done. The thing that I didn't mention on our process or our steps is that you can always check your work using the other equation, right? So we already used negative 3x plus 2y equals negative 10. Let's verify that x equals 2, y equals negative 2 is in fact the solution by putting those values into the other equation that we haven't, that we didn't use for our second step. So we have x is equal to 2. We have y equals negative 2. So I have 5 times 2 minus 4 times negative 2 equals 18. So that gives me 10. Can't see this very well. Let me fix it a little bit. This is a y. That was a negative 4. Negative 4 times negative 2 is positive 8. So we find out that 18 equals 18. That is true, right? So that means that we can be confident in our solution. Another way to check your answers is to go to Desmos.com and to graph both equations like we did in 2.1 and find the intersection of those two lines. Obviously, you're not going to be able to do that on an exam, whereas you can use this checking method on an exam. But if you're doing your homework, you can use Desmos to verify your answers.